Thank you. By the way, can you hear me in the back? We're good? Can you hear me in the back? All right, so we'll just do the mic into the camera and skip that. It's good to be here. Thank you for welcoming me. This is my first time at this campus, and yeah, it's been a great few hours so far. Before I jump in, I just wanted to do just kind of an exercise together. And so can everyone just close their eyes and take a deep breath and let it go. And keep them closed. And I want you to go back to yesterday when you were thinking about coming tonight, and just what were your intentions or goals for tonight. And try to reduce that to 1 or 2 words and focus on that. All right, open your eyes. Welcome to tomorrow. If anyone wants, you can share the word just by shouting it out.
Learning.
Fun.
Nice.
Creative.
Interactive.
Inspiring.
Inspiring.
Organized.
Organized. Okay. All right. Awesome. My word was impact, so I hope you can each take something away from this tonight, but also me the same. I'm looking to learn from you guys and engage together. So here's what we're going to do tonight. I'm going to spend a little bit of time talking about my background. I know that's kind of the theme of this series. I'm also going to talk about the company I co-founded called Tomorrow Lab. Then we'll get into me introducing what's called the Hardware Innovation Guide, which is this kind of new manual that we've put together. And this is the first time we're really publicly debuting it. It's a collection of ideas that we've collected from the past 15 years of doing client work all around product development. So we're going to run a little workshop with that. And then we'll take a break, and then you'll share your insights from that, and then we'll do a Q&A. Sound good? Okay, awesome. All right, guys, so as Wesley introduced, my name's Ted. I am a co-founder of Tomorrow Lab. Myself and my business partner, Pepin, founded the company. Hello.
Hi.
How's it going?
Great.
Good. We founded the company in New York in 2010. And yeah, it is a hardware invention studio. So what that means is that we combine engineering plus design, and we create new products for clients. That's really where my passion is. So I am an engineer and designer. I'll get to my education in a second, but I'm really excited about using design and engineering to solve big problems. And really how that happens is through entrepreneurship, starting new businesses, or even working with governments. And but also education. I do teach a lot, and I'm really happy to be here and working with you students. So a little bit more about that. I got my Bachelors of Engineering from Purdue. It was a specialized program of study called Inventive Design Engineering that really combined, I was on the art campus half the time doing design courses in furniture making, sketching, model making, 3D rendering, but then also on the engineering campus learning everything about electrical engineering, mechanical, systems engineering, etc. And I have a TED talk about this, but at the time I graduated, I didn't know if I wanted to be a designer or an engineer. And when I would go and interview for jobs, they would ask me and try to silo me between one or the other. And I wanted to combine it. So I went on to get a master's in industrial design from Georgia Tech in Atlanta. And that really allowed me to fuse those disciplines of design and engineering together. Also start to teach a little bit. And so continue to do that, teach at courses really around the world, including the Copenhagen Institute of Interaction Design, some courses in Philadelphia at Drexel, and Cranbrook Academy of Art. And I'll be teaching again in a School of Visual Arts in New York starting this spring. All right, that's enough about me. Gonna move on to the company. And I have a little video I'll play. This was created by Dropbox a couple years ago, and it explains what we do. So Let's give it a try. Anytime a product is brought into the world, it is someone's responsibility. We really don't need more of everything. I think what we actually need are better things. As a design studio, I think that we have a different approach as far as how we want other people outside of our field to understand what we do as designers and engineers.
So we work on a wide array of products, things as sober as medication adherence, to a lot of really fun stuff, agricultural sensors that can monitor soil conditions that promote organic farming. We created a new VR experience that projects an image on the inside of this visor, and what it allows you to do is feel like you're inside a spacesuit. By taking a lot of new technologies and applying them to human needs, we're able to create really impactful products in a variety of verticals. With each project, we're trying to respect something, whether that's someone's time or their life or the environment. And I feel like if the products that we create aren't at least doing one good thing, then we're really not doing this right.
Every single product we develop here, we have industrial designers to sketch out the design. We have mechanical engineers on the team to figure out how everything could be assembled. And all of this require us to work really closely together, and we get inspired by each other and figure out the best solution to solve the problem. We have a saying here, there's sort of like no such thing as thinking in a group. Thinking happens inside a person's head. And so we have to create tools and processes in which people can think together.
We're a small team that moves quickly, and we need to be able to share files from SolidWorks or 3D files to photography and video all the way to electrical files. And none of that software is online. It's all desktop software, and it requires a lot of processing power. So really what Dropbox allows us to do is almost take that desktop software and turn it into a web app.
It recognizes that the purpose of a company is to stay in flow and try and get things done very quickly and move on to the next thing. And it lets everyone collaborate without things getting in the way.
We really like to work on products that are first of their category or first of their kind. Anytime we're designing a product, we are hoping that it is intuitive to people, that it's helpful, that the design is sort of uplifting and fun to use.
The future is somewhat of a scary place for some people. For me, the uncertainty that's involved with looking towards the future is the exciting part. It's very easy to become discouraged by the progress of climate change or social injustice, and it's sometimes hard to see how what we're creating always fits into that larger solution to fix those problems. At the same time, it's really important to focus on the specific thing that you're developing. And if you can move the needle just a little bit, doing that will help us have some perspective on what we're trying to build in the future.
All right. Thank you, Dropbox. All right. So that kind of said what we do, but I'm going to say a lot of it again. So as the video mentions, we're a hardware invention studio, and the company was founded in 2010. With my background and my business partner's background, we try to hire other people like us. So that means those are hybrid people, folks who have an engineering background or a technical one, but also design. And it's really in this fusion of those disciplines that I think a lot of magic happens. And it's what we call holistic innovation. So like holistic, and we're really known for this holistic innovation approach where we combine those engineering disciplines with design. So I really think that the best products in the world come from a combined approach. A lot of firms, as you might start interviewing and getting to know, for jobs and things like that, you'll begin to notice that some firms are, again, more focused on engineering work, some more focused on design. And so we are really about combining those two in the very early stages. Here's 8 products that have recently launched. These are products that we designed years ago that have all come to market. And I'll describe a few of these. But what's common about all of these is that we met the entrepreneur when they just had an idea. And they brought us that idea, and we worked through a series of our process, our prototyping, and product development, and also bringing these into mass production so that now these entrepreneurs can build product businesses around those. Starting on the upper left, this is a product called Exponent. It won a Sustainability of Design Packaging Award from Dyeline in 2023. It's a cosmetic packaging, but it dispenses a dry powder and a liquid serum when you press it and you mix it and use it. The founder of this has built other consumer packaged goods companies and was really tired of shipping around water, and noticed that their customers really found that the freshness of the product was key to its use. This next product is called Simple Brush, and it is an all-mouth toothbrush, both for kids and adults. The clients behind this are a dentist couple in Manhattan, and they have their own dental practice. And we worked to first invent this idea of an all-mouth toothbrush. You might have seen others on the market that look like it, but they don't work like this, and I'll explain why later. But part of the innovation of this was to generate a folding bristle design that can clip into the product, made 100% out of nylon, so you can recycle it. And we spent a lot of time shaping the size of the cradle based on mouth data from that dentist. The following product is a hair care device. We invented it along with the founder. And what it's able to do is you're able to fill up pods with your own hair product, and it can extrude and heat it and basically summarize a lot and reduce the time that you're normally spending on that. It's called a Ritualist, by the way, and it was on Shark Tank and got a double investment into their product. The next product is a period equity device called Flow. It stores a lot of tampons and pads for a product of its size. And we developed some mechanisms inside to essentially prevent hoarding or taking lots of products all at once. So even though they're free, the brand wanted to make that free last a while for everyone. This was shown in the video. This is a VR space helmet that we created for the launch of a television series called One Strange Rock that was narrated by Will Smith. And the whole premise of the show is astronauts' view of Earth from space. And so we actually created a product quickly that all of these press people at the launch event could wear and actually experience that point of view as if you were an astronaut from space. And it looked cool too. This next product, it was called Daddy, but it was acquired by a company called Roe Healthcare. It's a sample preservation kit for fertility. And even though it looks simple, it's rather complex. There's a cup, you put your specimen in there, it deploys a preservative. That cup goes in this box. That box is filled with it's called PCM, or phase change material. It's a thermal battery that keeps that specimen at a really constant temperature for up to 48 hours while in shipment. And that plugs into testing clinics and cryogenic storage. The following product, it's called Terralytic. It is an agricultural sensor stake, and it gets buried in the earth. It's about 3 feet long, and there are sensors positioned along it, and it's actually measuring the conditions of the soil. It's watching it breathe. It's measuring the amendments in there, any fertilizers that may have been added, or even water. And it's sending all of that data wirelessly back over LoRa to a base station. And so if you're let's say you're Dole or a Tropicana, and you're managing thousands of acres of crop, a product like this can essentially help you use less water and keep an eye on the acres and acres that you're growing food in. Okay, and last is called HiveCell. This is a stacking supercomputer meant for edge computing. There's an NVIDIA chip in there, and we helped the client here actually come up with not only this form factor, but a series of magnetic stacking pogo pins that once you stack these together, it passes the Ethernet and the power, AC power, all the way through. And this is one example I'll get to later where a business model can inform the product design details. So I'll touch on that later. All right, and I already discussed that even though these are across way different industries, right? Like computing, agriculture, cosmetics, etc. What was common in all of these is that we worked through a process of invention and prototyping with the client and brought that into manufacturing. and there's been more. So I've been running Tomorrow Lab for 15 years with my business partner, Pepin, and we've worked on over 100 projects, close to 200 at this point. And there's always something to learn, and I'm always surprised by an insight that we worked on from this project can wind up informing something you didn't even expect. So not only do we work with entrepreneurs, but we work with big brands as well. And a lot of those teams inside of those organizations essentially just act like startups. There are 6 people, they're tasked with coming up with a new product, and they don't have time or they don't know how to do it as well. So that's why they would come to us. And we can come up with the right approach. And we have the equipment and the staff and the talent to do that. Part of how we do that is our space. As you guys know, you're probably in the shop a lot or in the studio a lot. Like when you're in the design of physical spaces and goods, you are making physical things. And to do that, you need tools and materials and space. And so our lab is calibrated with a lot of equipment, testing equipment, 3D printers, everything you have here. But really what we're intending to do is prototype and design the product, but then hand that off to a manufacturer. So yeah, our spaces are really designed not to make products, but they're to prototype and test, right? And I apologize, these first few slides are kind of like more business oriented, so there's a lot of information here. Just take what you can and whatever's important to you. As far as our capabilities, we do a lot. At the core of what we do, though, is prototyping. And this is really central to our business, and it's why people come to Tomorrow Lab, is they want a thing. I just want a prototype, is what I always hear. Okay, got it. Well, to get there, we have to do a lot of other things. We have to think about strategy. How are you going to sell this product, or who is it for? There's design. The industrial design, the look of the product, or the user interface if it has a screen. Supply chain is a big aspect as well. How are you going to get this made? Who is going to make it? What are the components involved? And then on the bottom, you have what I would call more traditional, engineering disciplines. So mechanical engineering, electrical engineering, and firmware. Firmware is the code, it's the software that lives on our products, right? At Tomorrow Lab, we don't work on apps, and that is a choice that we made very early on. We don't work on software because there are so many others who do. And so we really chose to laser focus on the hardware. But that said, as you can see, a lot of the products are connected devices. So we do have to work with software engineers, and we are often creating documentation so software engineers can talk to the products that we make. That's our capabilities. And as I mentioned, why do folks come to us? It's often to get more done, to improve their team, to move quickly, or just to explore something new. All right? So I'm now going to talk a little bit about some of the tools we use. I'll go into greater depth of them in a bit, but I wanted to highlight some important ones. So as far as product strategy is concerned, so this is figuring out, what is the product, who is it for? We have a few core tools we use. One is called state of the art. By the way, where is the state of the art table? If you look on your sheet, okay, it's right here. Awesome. So what is state of the art? Well, state of the art it can be a lot of things. It could be Amazon shopping. It could be going to a store and looking at competitors. It could be looking in your own home and seeing what similar products you have. So it's really about taking stock and looking at, hey, what other products are out there already that are similar to mine, and studying them, right? Next is teardowns. That's kind of a follow-on. I think you guys are the teardown table, right? So teardowns is simply the process of disassembly. But you can think about it almost as a Q&A or question and answer with a thing, right? So you're taking it apart to learn something. What components are inside? How does this work? How did they assemble those parts? Did they use screws or glue? There's a lot of questions that you can find when you take things apart, and a lot of lessons that you can learn and apply to your own product design. And then last is the innovation pathway. These first two kind of sum up into innovation pathway. By the way, who has innovation pathway? Okay, awesome. Over there. So the notions of innovation pathway is this product, first you have to say, okay, this product is meant to be scaled up. It's meant to be mass produced, right? Well, if I'm still at the design stage, what I need to do is I need to think ahead about how I'm going to scale this up, who's going to make it, and what might the different design features that I should consider now in my process, just starting to point those out. So let me take a step back just to give an example. I talked about this Hive Cell, right? Their business model was about selling computing power, right? So if that's what you're going to sell, well then if you're the industrial designer, a clever thing that we came up with was, well, why don't we literally allow you to stack the product and scale it, like literally scale the product to meet their business goals, to be able to just scale up instantly. So those little details then manifest themselves in the decisions you make early on in the product design and enable that type of business to even exist. Another good example is the razor blade approach, or like printers with ink, right? So if you're designing products like that, obviously there's a consumable component and then a durable one as well. And then of course that is not only how the products would be sold in the market, but the designers of those have to think about that at the outright, okay? That's innovation pathway. Few others. Who has design DNA? You guys have design DNA. Okay. So design DNA is really about it's what it sounds like. It's the DNA of your design. This is often communicated in what are called mood boards, right? Color, material, or finish of the design. It could also start as, hey, I want this product to feel really friendly, or this is about, bringing, or this is about safety. And that being integral to your product, you need to make design decisions to make sure that it looks like it's going to do the thing that you're promising. Who has feature strategy? You guys have feature strategy also? So feature strategy is essentially a list of the things that your product does. So I'll just, demo this. Features-wise, it has a laser pointer. It can advance my slides. It connects to the computer. It's battery powered. It fits in your hand. Those are all features. And the way that you kind of assemble those features together makes the product, right? And we'll get more into how you do that. And last, value chain. This kind of gets into the innovation pathways more, but this is about really being critical and saying, do I need this feature or can I leave it out? What value am I really getting by including it? This also involves how you're going to manufacture it. Let's say that I'm going to design a new remote and I want to manufacture that. It's going to be a lot easier for me if I find a maker of remotes already and I bring them my design. Okay. Going to move into some more like simpler stuff and some case studies. Good on time. Okay, prototypes. I know I've said that word a lot, and I know you guys do prototyping. We define 4 tiers of prototypes at Tomorrow Lab. And this, by the way, who has the fidelity frameworks? Is it back there? Okay, so this information's in there. There's a lot of different ways to talk about prototyping. One of the ways is to talk about this tiered approach. And it's based on the idea that first, you're never just creating one prototype, you're creating many of them. And sort of like, where do you start? So with a tier 0, which is where we always start, we call this a cosmetic model. So it's a picture or a 3D print, but it doesn't work It's just meant to represent the thing in physical form. But it's valuable because you can show it to people and you can get their feedback on that picture. Or you can put that 3D print in their hand and do ergonomic studies. Maybe you add a weight to it, or maybe you're evaluating colors, etc. There's a lot that can be done with that at just the picture stage. And then tiers 1, 2, and 3, these are works like and then looks like works like. So this is it just looks like it, and this is it works like it, and then we combine them. So with a tier 1, we call these benchtop demonstrators. This is when maybe you start with a teardown and you grab that motor and you grab that LED and you connect it, and it's like, okay, that's the core feature, right? Is the light turns on when the motor is on. Okay, great. You've prototyped just that feature. Well, then do tier 1 prototypes of all the features, right? And so we will break the product down into all of these different tier 1 prototypes and do those individually. And then the tier 2 is when we combine them. And so it's a looks like, works like prototype. Here we can actually begin to evaluate and test it and to push it to its limits. And then last, tier 3, this is a factory produced sample. So this is, before you're about to make many, many of them, this is what the factory is delivering to you. So that's, final specs, final material, final function, etc. And by the way, we don't just prototype to feel good about ourselves. We always do it for a reason. So we create a test before we prototype. So it's like, what do I want to learn from tier 0? Do I want to know if people like red or blue? So I will create a rendering and maybe a survey, and I'll find out. With a tier 1, I want to see if my new magnet hover concept works. So I'm going to build the magnet hover and see if that works, right? So on and so forth. And we use this testing and prototyping process to essentially learn from the prototypes that we're making and progress in fidelity. Okay. All right, we don't just work alone, by the way. We have a lot of partners. As I mentioned, we focus a lot on the prototypes. I'm saying that word a lot tonight. But there's a lot of other services that we can connect you with, both in the low volume and prototyping and medium to high. So for example, companies like these produce our circuit boards for us. Companies like these, we will send our CAD files and we'll get these amazing, painted real material prototypes that have been like CNC'd and look great. IP, you guys are in the back? Right. So that's often a concern, right? If you're investing all this money into the product, well, what if someone, steals my idea? So we work a lot with patent attorneys who are, trained in the area of patents and intellectual law to help you, the entrepreneurs through that. But then there's other things like, certifications like FCC. So, you don't melt people's brains with your new product, FDA, UL, et cetera. And then last, there's research and marketing. What's kind of interesting about this group is we rarely kind of work with research and marketing. And that's because the prototypes that we deliver are the research. And you can put it in people's hands and get feedback directly from there. And so, oftentimes our clients sometimes are feeding into crowdfund, but otherwise are coming with their own product strategy and testing it. Okay, a couple more minutes just about Tomorrow Lab. This is actually how we work. So there's 2, 4, 6, 7, 8, wait, I can't even count. 7 bubbles here. And when we're meeting a new client for the first time, one of my jobs is to figure out where in this process are they? Are they in the idea to prototype phase? Are they in the prototype to product? Or are they looking to scale this up, product to pilot production? There's a lot of P's. And once we get a feeling for where they're at in the process, then we will scope out a project. And this is what we call them. So we either have a 1 or 2 week accelerator workshop. There's our 4 to 8 week innovation sprint. We can do more traditional product development that takes months. Or once the thing is ready for manufacturing, we can help you find that manufacturer, make the thing cheaper, or even help with the regulatory compliance. Okay. Who has the this section, which is just the phases 1 through 4? Okay, awesome. So, and then who has the 12 phases? You guys, awesome. So overall, let me actually start here. We have a 12-phase process. I'm not going to go into all that, but what I am going to go into is the first 4, because I think this is always very relevant for any time you're starting with a new idea. Not to say that all the 12 phases aren't great. But we're just going to concentrate on these 4 right now. So our classic kind of holistic innovation sprint, this is what it looks like. And you guys can use this model in your own work and stretch it and compress it for however long you need. So what we do is there's discovery. And so first, this is about laying out all the information you have, doing your state-of-the-art research, doing your design DNA mood boards, doing some teardowns, right? And getting your head full of all that information. Then we go into the elements, and this is where we actually break out the 2 work streams of technical, so like the engineering stuff, and then the aesthetic or design. So actually we'll break into teams. And the technical folks, they're figuring out, well, based on the feature strategy, what components do we need to enable that? Oh, you want a wireless speaker? Okay, well, we need Bluetooth, we need a battery, we need a speaker, we need an audio driver, right? And they'll begin to lay that out in 3D space to begin to see, well, how big is this thing, or how can we shape it? Meanwhile, the design team, they're using the design DNA quiz and the features, and they're sketching. They're figuring out, what does this thing look like? What are the touch points? What materials do we need to use? What processes? And then in the 3rd phase, fusion, we smash those 2 things together. So we know the components and how they're laid out, and then we kind of know how the thing's going to look, and so we combine it. And this is what we call product architecture. So this is, imagine a cross-section of the product. How are all the different pieces laid out inside? And we'll get into physical prototyping with our tier 0s or tier 1s, and then we'll end with delivering one of the prototypes. So again, either it's a picture of it, which is informed by all this thinking, right? It's not just a drawing that we made up, or it's a tier 1 prototype where we're actually starting to prove and build the thing. And after that, you have more. These are all the development phase: engineering, integration, refinement, sampling, and then once you're in production, validation, pre-pilot, pilot, and scale. In each of these, there's a lot of supply chain engineering design activities that are happening. And again, this is for you to view. I didn't want to spend much time on the later phases. A little bit just more about the company. This is my business partner, Pepin, and myself. We founded the company with just a lot of hard work and long hours. Started when I was 26. And here are the images of kind of like what our business grew out of. Just was a desk that we paid a couple $100 for and slowly grew and like gathered employees. And now, actually last year we moved into the Greenpoint Manufacturing Design Center in Brooklyn, which is an incredible building where it's all makers. You have to make physical things to be a tenant there. And the city's done something great where they discount the rent for us, which helps. But it's actually an old rope mill, which is neat. So, making things is sort of in the bones of the building. And we have a lot of fabrication space here. And this is where all the magic happens. All right, 2 other things about the business, and then we're gonna shift into these. Do you guys watch YouTube? All right, so I have 2 channels for you to check out if you want. One is ours called, it's youtube.com/tomorrowlab. This is where all of our teardown videos live. If you're not annoyed with me talking, you can go in and watch those. No, they're entertaining. And we have guests on there. We did about 30 episodes over the years of taking things apart, just, showing what we found. And that ended up catching the attention of DigiKey, which is a component distributor. digikey.com. And so with the help of DigiKey, we now have a sponsored YouTube series that's basically like Tomorrow Lab made for YouTube. And we do our 4-phase process in these 10-minute videos. It's called Potentially Genius. And as you could guess, it's kind of like a thing where we try to make something potentially genius. But how it works is DigiKey brings us one of their components, and then we make something with it. It's almost like a Mission Impossible. And then we reveal it in the end as a surprise. But along the way, we film our process, the successes, the failures, and try to make it entertaining. Do you want to watch a little clip? Yeah, okay. This is the latest episode that just launched. We did this one with Arduino and their new plug and make kit.
Now that we're settled on a keyboard synth, we're starting to think about how to actually build out this device. So this is the folded state. Now the handle flips down like this, and the whole thing stands up. Then you unclip this from the back. This is the standing position. So basically you'll play the keyboard here in the front, like this. And when you're done, you can just fold it back up and take it with you.
What you're looking at here is what's going to go on our PCB. We have a capacitive touch breakout, and all of these are the keys. And these are the modulinos that came with the plug and make kit.
So what does this one do?
This makes a sound. So, the capacitive keys, you can touch it, and it makes a sound.
What do these buttons do?
Right now I've coded them so that it can adjust octave.
Mm-hmm. Cool. And then what's this last one do?
The TOF sensor senses the distance between your hand and the sensor, and it adjusts the frequency of the keys. So I think we're going to make a PCB for this, and then once we design the PCB, we can put everything on there. We'll have more keys, and we can put the PCB on a clean surface and make it look nice with the 3D printer.
The first step in this assembly is to add a few heat set inserts. When we 3D print plastic parts, sometimes we want to be able to add screws, and you can't 3D print screw threads very easily, so we have these brass threaded inserts. They have threads already in them, and with a hot soldering iron, you can just melt them into the plastic, sink them in, and then you have screw threads ready to go. From our sketches, we like the idea of this folding frame that works as a kickstand, so this was the first version of that. It's okay, it works. It flips up like this. The Arduino board sits in here, and you can use it as a carry handle or flip it down like this for stowing. But it's a little bit flimsy, and when you fold it flat, it kind of has this like really skinny profile to it. This doesn't look very nice.
So this chunkier form factor starts with the same kind of idea for a frame that holds the build plate that comes with the modulinos. And this is going to have heat set inserts throughout, so you can screw directly into this rather than having to fiddle with nuts on the back.
Then we have the keyboard PCB itself, and this is a placeholder right now. We've ordered a custom board. This is just a 3D printed block to represent it, but it goes in this printed frame, clips into the back with some magnets here, and then you can stash it for when you're taking it with you, and you just pull it out like this. And we can assemble this handle to show you how that goes. To play it, you flip this up, stand it up, put the keyboard here, plug everything in, and we will have these extra modulinos up here for control. Screwed in here, and there's your synth. Just like that.
So this was my first time to actually design a capacitive PCB.
All right, you can watch more on YouTube. Okay, let's just do a quick time check. And, all right, let me blaze through these. There's 3 products I just want to go a little bit more into like what we did in the prototyping process. First was the simple brush I mentioned earlier. Here's some really early visualizations, some intern sketches, some other things we did, some 3D models. What we were trying to really figure out here was how to fit and clean all of your top teeth and then bottom teeth at once. So how to fit that whole thing inside your mouth, but then also have a pretty simple design for the handle with just one button. As I mentioned earlier, one of the core innovations of this is this folding bristle tray. You can see some tier 1 prototypes we made over here. Well, maybe this is like tier 1.5, and a lot of design artifacts. But initially, we had handmade these bristles by like trimming the, what's that called? Anyway, some of the bristles you'd find on a broom, and then hand gluing them onto a substrate. And bit by bit, we were able to refine that to the point where we started working with a factory agent who connected us with a CNC tufting factory. Those are the ones who make toothbrushes. And we were able to innovate with a factory to essentially turn their toothbrush machine into this folding bristle tray machine. And so what happens, the way these things are made is just thousands of bristles are planted really quickly. That's a little bit about that process. And what's unique is not only is it for children and adults, but it's also used for folks who maybe don't have access to both of their hands or don't have two hands or have limited mobility, because the product is basically doing all the brushing for you. All right, next is this Teralytic wireless sensor stake. As I mentioned, this gets buried in the earth and it measures all these different qualities about the soil. How we do that is there are 3 sensor nodes along the length of the product. And that's because crops have different root depths. So if you're growing soybeans versus a tree, the soybean roots will only reach 6 to 12 inches while the trees are reaching deeper. Imagine this rotated. So that's why we duplicated those sensors along the length. And where we started this process was here. These are tier 1 prototypes. We bought individual sensors for oxygen sensor, carbon dioxide, pH, EC, and moisture. These are just tubes. The sensor was somewhere up here. But individually, we demonstrated that we were able to measure the quality and that we needed and in soil. And then the next step was to fold all of these into this sort of like razor blade package, right? So this is the module that lives in each of these 3 places. And those wear out over time because they're buried in the earth. And when it's buried in the earth, things decompose. So we needed to make those swappable and modular, right? So that informed a lot of that design. There was one area that we didn't develop, and that was this thing called a ChemFET sensor. It's a microscopic view of it. And it's a transistor that's doped with a certain chemical that changes resistance in the presence of other materials. So, for example, you can create a ChemFET to measure salt or calcium or phosphorus or nitrogen or all the other things that make plants grow. And so those little things went into that, and those went into our sensor stake. I just wanted to show this because sometimes we're not creating everything. Other times we are, inheriting components from other suppliers that we need to fit into our product. There's that. You can see the final iteration, we have a little screw here. So with one screw, you can take that whole module out and put a new one in. All right, and last was this Nat Geo space helmet. So again, we created this for a TV series launch. And what's unique about this project, by the way, is that we did it for an advertising company. So the client, their goal was really about visibility and like a wow factor. And we had, I think it was like 2 months to not only come up with this concept, prototype it, but also deliver 15 of these helmets. So we started with some core principles of wanting to view the image that you're seeing from the outside, so almost having this like rear projection screen. And we also wanted almost an IMAX experience. So we wanted you to feel like it's a 360 degree or 180 degree view, but it couldn't be too big or else this helmet would be enormous. So we ended up sourcing a laser projector from Sony that we disassembled just a little bit. We connected a Raspberry Pi that's running a video, added a sound system, and we did a whole design development process for these helmets that were then produced using a process called MJF, which is a large-scale 3D printer, and produced, again, a couple dozen of these. And this was the press event. So these press came expecting to watch the debut on a TV, or on the screen, and instead we came and put a helmet on each one, and we synchronized the video stream so they're all watching the debut in these helmets. These are now at different science and space museums across the country. Okay. So let's go into this hardware innovation guide. And yeah, so what is it? So this is intended to do a few things. It's intended to equip teams who are working on new hardware products with really a lot of best practices that we've gathered over the years. And it's arranged in a way where we move from concept planning to execution. And I'm teaching a course this spring at the School of Visual Arts, and we're going to be using this really as like the course book. But you guys are really the first to see this. It's a public debut tonight, and I'm excited to share it with you. So what we're going to do after I just run through it is you're already in your tables. On each of the tables is one of the sections, and I want you to do two things. One is think about and discuss with each other, how does this section relate to your own work, right? I know you're in classwork right now, or some of you guys are in the junior planning studio. How can you apply this to your own work, and what is that specifically? And then second, I want suggestions. If there's something confusing in there, or something missing, or you have other ideas, I'd love to know that. And then after the break, what we'll do is each table will just share out for 4 minutes, and then we'll do that Q&A. So let me go through, because I know everyone does not have the whole guide. I'm going to go through it here. So Hardware Innovation Guide, from idea to prototype. This is the intro page. As I mentioned, the first few sections are all around planning your work, and then the last sections are around working your plan. So it's more intellectual thinking and then doing in the end. Okay, so number one, the 12 phases. As I went through, this is how we structure all of our work at Tomorrow Lab, from idea to prototype to product, and get it into mass production. This is really relevant for folks who are just trying to understand that whole process. For the phases 1 through 4, this is just a zoom in of the first first 4 phases, which you now know we call that holistic innovation sprint, of the discovery, elements, fusion, and vision. This is also the potentially genius format. So we do this, these 4 phases a lot. These are split into design and engineering tasks. Then we have our state of the art. It's about doing competitive product research, or analogous product, meaning, if I have an idea for Bluetooth in a toothbrush, maybe I want to look at Bluetooth in a dog collar and see how they did it. Even though it's not a toothbrush, it relates in some way, right? So you're able to study features from other products and leverage that in your own. Paying attention to others' industrial design is important in order to establish your own brand and identity, and also costs. With state of the art. So understanding if there's a competitor out there and they're really expensive, or maybe they're really cheap, why? How are they able to do that? With teardowns, I've spoken about this a few times. As I mentioned, teardowns is really about question and answer with a thing. You can save so much time by looking at how others have done it rather than doing it yourself. So this is really why we do teardowns. That ritualist hair care device I showed at the beginning? These are actual photos that we did of teardowns when we knew the product needed to heat up and pump out a material. So we tore down automatic soap pumps and for bathrooms, and then also hot hair tools to see how they're constructed, see what safety mechanisms are inside, see how they mounted the components inside, all of those things. And that saved us, even though the intention is not to copy, the intention is to be informed. But seeing how others have done it will save you hours or weeks or more of work sometimes. So yes, you can learn from how others do it, understand how it's done, absorb best practices, know the competition, and allow you to innovate. Design DNA. This is our color, material, and finish mood boards. These are some examples up here of well-known family brands like KitchenAid or Google or even Logitech. You know, I'm sure you guys have gone through this in your industrial design courses, but the idea of a brand language in a product line, this is really what this is all about, and getting to the root of that and developing your own. So not only can you study the existing product's design language and their choices, but then you can, again, make your own mood boards. Things like how can color communicate cleanliness, or how Google chose to put fabric in their products to make it friendly and like it'll fit in your home, or how Logitech has these precise, sharp edges to kind of communicate precision and technology. Those are all choices that are made. Okay, then going on to feature strategy. By the way, this group, you have 3 pages. Sorry, this was like a big section. And so this is really about summing it all together. And we're starting with some glossary terms here, but also different ways about how you're going to take your product concept and refine it through prototyping, testing different combinations, using feature brainstorming and road mapping. Next, this is the innovation pathways. So once you have your product concept, how do you, bless you, how do you think about its sales models or how it will be manufactured to inform some decisions? And some key things I'll call out here: buy versus build, right? Every product is made from certain things that are designed or built, and others that are bought. So for example, this product probably has a lot of screws in it. The manufacturer of this will likely buy those screws. They're not going to manufacture the screws necessarily, right? But then Logitech, they want to have this unique shape. So, you know, they'll definitely make the housing and mold that. And maybe they're sourcing the electronic set from someone else. A really simplified way of thinking about that is just this image. This is a 3D printed housing that's built, and that's a battery that you would buy. And then you're essentially doing those decisions dozens, hundreds, thousands of times for every component that you create that goes into the product. And the point is, though, you can't buy everything, right? Because then there's nothing unique about your product. But you also can't build everything from scratch, because then that will be a very long process that's expensive. So it's really about a balance of this buy versus build. And your job as inventors and designers is to really concentrate on what is the core thing that I need to build, and just buy everything else, right? Or source it. And yeah, I talked about this example of looking at the sales model and how can that inform your product design. So I talked about how the sales folks at HiveCell literally sell scalable computing, and so the product design needed to scale physically. The razor blade approach, subscription or eco-leasing, or even the freemium model, like do you sell a product where they can buy add-ons? Or is the product not even meant to be owned, like a shared scooter or a shared bike? In those instances, you need to think about, well, how will multiple people use this product if it's going to be shared? All right, let's see. I'm still in innovation pathways. Also in here is thinking about levels of invention and kind of just doing a gut check in your own ambition. We love tiers. There's different tiers of invention, from something that's a minor reconfiguration all the way up to something that has never been made before. And I'll tell you a story right now. So there's been one product over the hundreds that we've worked on where it was a tier 4 invention. And so the client came to us with, and by the way, this is like a sophisticated Silicon Valley investor type, who apparently had knowledge that a certain sound frequency could put out fire. And there's this like ancient knowledge about this, and this was like this was the idea. And so he wanted us to create a device that used sound waves to put out fire. Well, are you guys aware of any product like that? No, right? So the first step is we needed to prove that was real. And we looked at DARPA papers, videos online. We're researching all these academic papers. We kind of found a little bit of science that made sense, where you could use pressure and velocity to like create vacuums in air. And then of course, fire can't burn in air, or sorry, fire requires air to burn. So if you create a vacuum, maybe you could put it out. So we prototyped this thing to heck, and long story long, it was fake science. You cannot put out, at least we were not able to, extinguish even the basic flame with the notion of moving air at certain patterns. And so, we told the client, and, that was the project. And oftentimes, even though it might seem like a waste at the beginning, knowing what not to do, knowing what not to invest in can be as valuable as knowing what to invest in, right? So, that was an interesting project. Levels of invention. I talked about developing novel features first, really concentrating on what that thing is, and leveraging partners and suppliers means, if you're trying to make a toothbrush, try to find a toothbrush factory, because they're going to bring a lot of knowledge to you. Almost at the end here. Okay, prototyping strategy. So now you have it all figured out and planned out. You're ready to do it. So how do we do it? Well, first, why are you prototyping? The whole point is to de-risk and make decisions early on. And that's because the cost of a change increases the farther you go. And right now, if you were to come up with a new idea, the decision of if it's blue or red, that's a free choice to make right now. But if that thing is in manufacturing, and then and it's blue, and you said, no, I want all them to be red, well, that's a very expensive choice to make, right? And so part of prototyping is to try to make all those decisions when they don't cost a lot, or they're free. So that's the cost of a change increases. That's why we prototype. Also keep in mind who you're prototyping for. I generally break this into two audiences. There's people like us, designers and engineers, and then there's the others, kind of the early users or investors. And I think the core difference is, like, everyone here, because of the background and training you're going through, you are able to imagine essentially gaps in other people's work. So when you see a sketch, you're able to imagine, like, oh yeah, I can see that. Yeah, that was cool. Yeah, there'll be a screen there, and like, you kind of add your own imagination to it, and you're able to fill in the gaps. But others aren't able to do that, right? They don't have the training or the background or experience in designing products in the first place, so they cannot imagine past what they see. And I bring this example. This was a shaving product we created many years ago. It's a shaving cup where it just uses a little bit of water and cleans your blade. This was the final product. But before that, we had a tier 2 prototype. Those two things do the same, right? It recycles water, it cleans your blade. But the problem was, with this thing, it was so big that the early users were like, I don't know where I'm going to put that in my bathroom. And they just rejected the whole product concept because they couldn't envision it ever getting as small as that. Whereas other designers and engineers can be like, okay, yeah, it would just be smaller. I'll just evaluate, the use right now. I'll wait on judging the form. So be aware of that when you're prototyping and showing it to others. So you're ready to prototype. Different ways to do it. We have this cycle called learn, make, test, break, where you learn everything about what you're trying to do, you make something, and you test it to the point of breaking, and then you observe how it breaks. And that is a cycle that continues, right? Because how it fails, or why someone doesn't like it, is what you go back to learn from. And you can loop that. Some other prototyping strategies I like to talk about are fine brush, broad brush. This is kind of like a visual example, but when you guys choose to dive into how you are generating your ideas, keep in mind what tools you're using. And so I use this metaphor of a brush. If you're at the very beginning, don't go for the really fine brush, because then you're going to be forced into all of these decisions you're not ready to make. You want to choose a big brush, like just a really quick sketch, because you just want the overall bird's eye view of what you're trying to create and not be forced into making all the decisions. So like from the electrical side, you would start more with circuit board diagrams as opposed to designing the PCB. Or for industrial design, you're going to start with a pencil sketch before you jump into computer renderings, right? And this helps you pace the decisions and time you're investing, which is also communicated in this notion of 6 6s, which essentially just talks about the different ways you can invest your time and money into making stuff. In 6 seconds, you can do a whiteboard sketch. It's free. In 6 minutes, you can build a foam core model. In 6 hours, you can do a 3D print. It's starting to cost money. In 6 days, you could do an integrated prototype, and that's maybe hundreds of dollars in components. In 6 weeks, you could build more of those and test it. And then, in 6 months, you're transitioning to manufacturing and investing a lot of money. So just think about that and how time and money scales. Already talked about the four prototyping tiers, but wanted to combine that with the idea of looks like, works like. And this is not ours, but you'll see this in the industry. It's called TRL. It's Total Request Live. I'm just kidding. It's 10 technology readiness levels. NASA invented this in the 1970s. It's 10 levels from, again, idea to product. We don't use this because we're so concentrated on those early stages. This is just too much for us, too broad. And also, this doesn't reflect market viability. It's just performance. So it's really just how ready is a technology. Okay, and then last, we have IP. I'm not a patent attorney, but we do create a lot of patentable products, and I have my name on many patents. So I'm familiar with the process, and it's important for you guys to be a little bit familiar with it as well, because it's about how can you protect your ideas or how can you share them with others. So there's key IP frameworks like patents, copyrights, trademarks, and trade secrets. And there's also the whole collaborative frameworks like copyleft or open source hardware, where, again, you are intending for others to copy your design. What's kind of interesting is a lot of the technology in our world is built on this open source stuff. Everything from Linux or Unix to early MP3 or audio compression files. You can look in your Apple terms and service. There's all these open source things they use. I have a big passion for this. It is hard to sell to clients, though. All right, and then I just end up with talking about the types of patents, because that is most relevant for physical products and the value of them. And that's it. Okay. So that was a introduction to these tools. I'd love for us to now, I'm going to stop talking for a while. And if you guys can take the next 20 minutes. Does anyone have questions about the exercise, like what the intent is? Let me just go back. So it's up here. Yeah, that's it. So again, kind of looking for 2 insights. 1, how does this section relate to your work? And then 2, suggestions to improve the section. And let's take the next 15 minutes to do that. We'll take a quick break, and then after the break, we'll share out 4 minutes per table. And I'll float around in the meanwhile.